Okay, there are things about it I don't like either.
It just was weird.
Like, I don't know where it's recording. Like, is it recording the entire screen? I don't know.
And why is it like
Maybe?
it's like a border? Yeah.
I don't
A
know.
white border.
I think it's recording the whole screen. I don't know. But it's definitely not like, it's not as laggy as it used to be. It's got that going for it. So, okay. So, work. Maybe I need to focus this a little better. I don't know why I would need to focus it better because it's the same stupid camera I was using on the Windows side. Why does Macintosh need it? I don't, never mind. Ah! I hate this company. Well, it's the most aggressively anti-consumer company. Anyway. Okay.
Microsoft.
No! Apple.
Apple.
Yes. Yes, I can.
Microsoft is the bomb.
Okay. So back to this. So let's say that we have a one of those conical cups that you are sipping a beverage from, and yeah, it's conical. Yep. And because a conical cup, yeah, sure, a snow cone cup, but you're not drinking a snow cone from it. You're drinking a beverage. Because you're a weirdo. And not only are you drinking a beverage from it, but you're drinking a beverage from this conical cup using a straw. Because you're a super weirdo. This conical cup is 6 inches tall. And it has at its widest point, it has a 2-inch radius. But obviously that 2-inch radius isn't kept constant all the way down because it's a cone. The straw protrudes 4 inches above the top of the cone. And we're going to say that your beverage fills this cone all the way to the top.
What was the 2 inches?
The 2 inches is the radius at the top of the cone. So the radius of the cone...
4 inches is how long the straw sticks up?
Mm-hmm.
Okay.
From the tippy top of the cone.
And the 6 inches
Is how tall the cone is. Yep, from bottom to top. Okay? Now, we want to know, let's say that you have filled your cone, or this beverage, or you have filled this conical cup, yep, conical cup, with a beverage that has a density, so your beverage has a density equal to water, which is 0.5787 ounces per cubic inch. This is another reason why the metric system is just so much better.
Isn't it just one?
Yeah, it's one gram per cubic centimeter, whereas ours is 0.5787 ounces per cubic inch. It's stupid. Our unit of measurement is just
You gotta be way smarter to use
sure, or be real dumb to come up with it. Anyway,
Why? Some genius just figured out a bunch of stuff that you nailed.
all right. So how much work did I grow up during the Cold War? Am I really a KGB spy?
Yeah.
Summer agent is like the right word. Set you off.
So how much work is it going to take to drink the cup dry? So it was like somebody going to come in with like a journal one day and read a list of 5 words at me. I'm just going to go crazy,
Yep.
kill everybody.
Yeah, but like it's gotta be words that aren't said very often.
Mm-hmm. That's
No, GIF is said a lot. It's
right.
GIF
So it has to be
not said
GIF.
very much.
Okay. All right.
Maybe something like that with comic books.
So, okay. So we're going to say that, all right, so work is equal to force times distance times cosine theta. And theta is the angle between the displacement and the force. Now, I know that I drew it so that the straw is kind of canted at an angle, but let's assume that like you're drinking it with the straw straight up, like you're standing directly over your drink, so that the force and the displacement are happening in the same direction, so that there is no angle between the displacement and the force.
So then, cosine theta is 1.
Right, so that cosine theta would be 1, so that theta is 0, and the cosine of 0 is 1. So we're going to make this whole thing here just be 1, and we can forget it for the rest of the equation. All right, so now we got to worry about the force, and we got to worry about the distance. So let's talk about the force first. So the force is going to be, like, let's imagine that we've broken up this cone into tiny little sections. So we've got like little cone section, cone section, cone section, cone section.
You can drink in one gulp.
Sure. Not a gulp, but like a sip, because this is a little tiny conical cup. Because you could probably drink that whole thing down just like in one thing. But you're sipping it through a straw, because you're a manly man. So like you're doing like a little sip, and you're doing like a little bit right there. Little sip, little sip, little sip, little sip. So we're breaking this down, and we're going to assume that this is going to be roughly equivalent to a bunch of little cylinders. So like this here, we're going to break it into a right cylinder, and then we're going to break this into a right cylinder, and this into a right cylinder, and this into a right cylinder, right cylinder, right cylinder, right cylinder. So we're going to add up the volume of each of those right cylinders. Kind of, sort of?
Isn't there some other way we can?
Would it be a cone at the bottom though, because you have the tip?
Well, we're going to assume that they're all right cylinders all the way down. Okay? So we're going to get to the calculus part here. But for now, we're going to assume that they're all right cylinders. You with me? All right. So what's the volume of a cylinder? Come on, guys.
Pi r squared times height.
There we go. So pi r squared h. So for this very first cylinder, we already know what r is. And the height would be whatever we say it is. So like, we'll just call it delta x. Right? And then it would be however much it's changed here would be the new r. And we do pi r squared times delta x. And then we do pi r squared delta x, pi r squared delta x. So we'd really only know that very first cylinder. Does that make any sense?
Yeah.
Is there a way we can do this, or we don't have to have them roll up?
We're getting there, Kim. We're getting there. Calculus is the easier way to do it, and we're getting there. Notice how I haven't really written anything down yet.
Yeah.
We're getting there.
Okay.
All right, so the next part here comes from the relationship between the 6 and the 2. So if I were to draw this out as a triangle here, I'd have 6 on one side, 2 on the other side. If I were to pick any point at random here and draw a similar triangle, like say that I'm drawing another triangle here that's going to have the same proportional dimensions, like say that this is x and y. This side here has to be 3 times the length of that side there,
Yeah.
right? Do you guys agree with me?
Yeah.
If I'm making this smaller version of that, then the length or the height has to be 3 times however wide it is. Does that make sense?
Yeah.
So the radius, this distance here, has to always be 1/3 of however tall it is. Right? You guys with me on that? Maria, you look like you're super not in the mood for this today.
No, I'm good. I just had a really big lunch and I'm kind of
Okay.
I'm not gonna fall asleep.
Okay. So I'm actually going to switch these. I meant for this to be y and this to be x, so just bear with me for a second.
So x is 1/3 y.
Yeah. So x is equal to, I'm going to say x is equal to y over 3. All right. So here's where the calculus comes in. So I'm going to say force is equal to pi times radius, but the radius isn't always going to be 2. So if I'm going to just like generalize it,
Y over 3.
yep, y over 3, quantity squared. And then I'm going to multiply that by the density of the liquid.
So,
And the density of the liquid is 0.5787. And I'm going to leave the units off for a second. I'll come back to the units in a minute. But the
We
units...
already know what the units are gonna be, right? They're gonna be foot pounds.
No. In this example, it's not going to be foot pounds. And I'll explain why. Okay. So this is the force. All right. Now, the displacement or the distance that we're going to be traveling is going to be a little different for this example.
Is it 10, or do you have to suck up to the 10 straw?
It's not quite 10 because it's not always going to be 10 because, like, it's going to be 10 at the very, very end, but it's not always going to be 10. Sometimes you're only taking it up 4 inches. Sometimes you're taking it up 4.1, 4.2,
Would it
4.3.
always be 10 though, because you're sucking it from the bottom? Of your straw to
yeah.
Okay, so like, yes, but your amount of displacement though, the force that you're taking it up from, yes, you are taking it up from the bottom always, but the amount of force that you're using,
Oh, because there isn't as much to suck out. So it
Right.
doesn't take as much.
the force of the displacement, even if you're pulling it from the bottom, if you've got it up to here, the force of the displacement only counts to take it from 6 to 4, or from 6 to 10, so it only counts as 4 inches of displacement.
So is it 4 plus delta 10?
It's going to be, we're counting it as 10 minus y. Because, like, we're counting this as, like, the y direction here.
Would that be the same thing?
Kind of, yeah. Kind of, sort of. So, now, Kim,
Yeah.
because you were asking for the easier way instead of having to add that all up. So, we're going to integrate this from 0 to 6. And we're going to do force times distance times 1, so we can just leave the 1 off. So, force is pi times y over 3 quantity squared times 0.5787 times, in parentheses, 10 minus y and dy because we're integrating it
Why? How about the,
because we're using y as our variable here
oh,
because we're going up. Okay, and now when we integrate this, we're going to be able to find out how much work is done to drink our little teeny tiny manly drink. Maybe it has a like umbrella in it. Who knows?
Oh, then you have to factor that in.
Probably.
That's not
We'll just assume that it's going to be okay though. So,
Maybe it's an umbrella taped to the outside.
okay. Couple things here. I'm going to add the pi and the 0.5787 together. I'm going to add the pi and the 0.5787 together, and I'm just going to call it 0.5787 pi. And then I'm going to have, I'm going to turn this into y squared over 9 times 10 minus y, and then dy. Is that okay? Did I skip too many steps? Okay. Now I can distribute y squared over 9 to both things inside the parentheses. So I've got 0.5787 pi. And then I've got times, let's do, sure, 10y squared over 9 minus 10y cubed over, or no, sorry, not 10y cubed. Y cubed over 9. You're right. I'm an imperfect person. I made a mistake. Stop yelling. And this is integrated from 0 to 6. And then I'm going to redistribute that 0.5787 pi to both things inside. From 0 to 6. 5787 pi. Well, okay, if I multiply that by 10, so then it's 57.87.
Or isn't it 5.87?
Hey, you're right. I'm off by a factor of 10. I made a similar mistake yesterday. Mr. Schwager called me on it. I was off by a factor of 10 in a teacher meeting, no less. Right? Times y squared over 9 minus 0.5787 pi y cubed over 9 dy. Okay, and then we got to integrate this feller. I was gonna say something inappropriate there. We got to integrate this feller.
Oh, I know.
No, you don't.
I'm good.
I was gonna be super creative.
Oh, really?
I wasn't gonna be standard.
Oh, now I want to know.
I wasn't gonna be basic.
Please, let's figure out those
How
like
many pepper bugs?
Please say.
Convince you.
5.787 pi. No.
I'll show you memes. Yeah, 6 pens.
I have Imager. Like I get memes.
You mean Inger?
No, it's Imager. Good lord. What are you doing to the English language? It did not deserve this.
throwing in extra vowels that aren't there.
We're butchering it.
No, we
Um,
aren't, Kim. You might be the only one that butchers it.
Over 36. And we're integrating this from 0 to 6.
You don't even have room to talk.
Okay. Now let's talk about the okay, so while you guys go ahead and do that, I already know what the answer is. While you guys go ahead and do that, let's talk about the unit of measurement here. So pi is pi. Pi has no units. Y cubed over 3. This was
Is that a Y to the fourth or the sixth?
this is y to the 4th over 3. This was in terms of inches. So this is going to be inches squared. So inches squared is going to cancel out with 1 of the inches from each. You're absolutely right, I did. How dare I? The nerve. They should take away my teaching license.
Everyone is lost in this.
Everybody makes mistakes, Mr. Cap. That's not perfect.
You're absolutely right. So we have inches squared here, and then we have plain inches here. So we've got inches cubed, and then we're going to take the inches away from those. So we're going to be left with ounce. We should be left with ounce inches. Ounce inches, yeah. Instead of foot pounds, it's ounce inches. Yeah. So
Hey, can we start using metric units?
you should be doing that already in physics.
I know, but can we use them in here?
The textbook isn't set up to do that.
Oh.
I mean, I can change it, sure.
Why would you want to do that? Are you communist? That is the un-American thing to do.
Are you one of Putin's spies? Are you from the FSB?
It's so much easier in metric. Sounds like
Are you from the FSB, Kim? The KGB isn't a thing anymore. It's the FSB now.
I said that time travel.
Mm.
Did you get some stuff? Huh? Did you get some? Yeah. Like my copy stuff.
Hey, what'd you get?
I have a
It should be 99 point something.
I was not right.
What did you get?
1.9.
That's what I got.
Oh, sorry. No, I was looking at the wrong one. That's what it is.
Oh, okay.
I was looking at the wrong one.
I was like, okay.
So what you
Calculators.
I was looking at the wrong one.
Okay, cool.
So what you guys get?
Bro, he's the
1.949 ounces
Yeah.
to the inch.
Ounce inches. The units is ounce inches.
So is it just inch?
No, it's ounce inches.
Oh.
Just like work was foot pounds.
Oh, yeah.
This will be ounce inches.
So it's just OZ-IN.
Mm-hmm. That's how much work it would take for you to drink your tasty beverage out of your conical cup up your straw. In case you were ever wondering. I'm sure that was 100% classroom appropriate, would you say?
It was actually very appropriate.
Okay,
It was kind of funny. It was appropriate.
great. So, our assignment, and I'll go through part of it with you guys if you want me to. is going to be 5-3. So we're going to be 5-3, page 8, 1 through 7. Because it resets every time.
Editing 8 pages is late.
Yep.